So I know that this is my x coordinate, that's my y coordinate. I'm just going to put a point here. We're going to call this point 3, 1. Now, if I wanted to travel to this point the long way around, I know that I'd have to travel 3 units in this direction and 1 unit in the y direction. This is x, this is y, this is negative x, and over here is your negative y values. All right, so we know that this is 0 degrees. This is 90 degrees up here as we go around in our protractor kind of vibe, 270, 0 or 360 degrees, depending on which one. All right, so I'm going to create a triangle over here by taking my point of origin and connecting it to my, hopefully I can draw it better because that is embarrassing. Let's try that again. Ha, there we go. Very nicely done. All right, so this is our 90-degree angle. We know that if we're going to measure the angle of this particular coordinate, we're going to look at our theta being over here. So first thing we're going to do is we're going to calculate for r. It says here determine r. So we're going to go r is equal to, again, it's Pythagoras because we're looking for the hypotenuse, right? We're going to take the square root of 1 squared plus 3 squared. And therefore r will equal to 1 squared is just 1 plus 3 squared, which is 9. So 1 plus 9 is 10. So r is just going to be the square root of 10. Remember, if it gives us a surd, much like this one, don't put it into your calculator and give us like a 3,1 something something. No, we don't want that. You're just going to give us the actual square rooted number that they give you. So we're just going to leave it as square root 10. All right, that's the first thing. Now they want us to look at sine of theta. Now I know that according to SOHCAHTOA, sine is opposite over hypotenuse. So the sine of theta over here is equal to, if I label, this is my adjacent, this is my opposite, and that is my hypotenuse. Right, sine of theta is equal to opposite over hypotenuse, which is 1 over, not 10. It is the square root of 10. So sine of theta will be 1 over root 10. And if I want to find theta, I know that theta is an angle. And I know whenever I look for angles, I must click shift. Right. So I know that theta is going to equal to, it doesn't matter which one of these I use. I could use sine, cos, or tan. It doesn't matter. I have all of them. So I'm going to use arctan of, and I remember tan is opposite over adjacent. So my opposite is 1 over my adjacent, which is 3. I'm going to ask somebody to give me an answer for this because I don't have a calculator near me. Somebody help me. What answer do we get here, folks?
Ma'am?
Yes.
The answer is 18,43 or 40. Wait, ma'am.
Like
If the number is
4,
under 5, it goes to.
yeah. No, it stays the same.
Okay.
Okay, so this is going to be, is it 43?
Yes, ma'am.
All right, beautiful. Thank you.
So
18,43 degrees. Let's not forget the degrees. All right. Okay, now I see a lot of people just joined as I was speaking. So welcome to everybody who's just joining us. If it's your first time with us, welcome to Maths Live. I see somebody named Sally. Sally, I don't know if you're joining us for the first time. If you are, welcome to Maths Live. It's so great to see you. Hello, Morangi. Lovely to see you. All right, we're going to continue talking a little bit more about trigonometry on the Cartesian plane. But the point that we're trying to get to today is not actually the Cartesian plane. We want to get to questions that are a little bit more challenging. And they're not just, we're not just looking at easy Cartesian plane questions where we're not really challenged in any way. No, we're going to be looking at things that are going to move us a little bit more today. All right, but first we're going to start with this question over here. Okay, I think we did this question in the last lesson, but I want us to quickly reiterate that if I ask you guys over here, I need you guys to find me the radius r, and I need you guys to find me theta, right? So we said that this is 0 degrees, this over here is 90 degrees, 180 degrees, 270 degrees, And this again is 360 degrees. Now, I'm going to ask everybody to quickly find me the length of r over here. R is equal to something. You can use Pythagoras to find us r. You can pop your answer. You don't have to pop your favorite emoji. Just pop your answer in the chat for me. This is quite an easy one, to be honest. What do we get for our radius in this particular question, or our hypotenuse is what we're looking for?
Ma'am, is r equals to 5.
It is, absolutely, it's equal to 5. Thank you very much, Sia. Absolutely, r is the square root of -3 all squared plus 4 all squared. Now, I know that any negative number squared will become a positive number. So this then becomes the square root of -3 squared becomes positive 9 plus 4 squared, which is 16. This is the square root of 25, which is indeed equal to 5. Thank you very much, Sia. So this is going to be 5. Now, we want to find theta. I'm just going to fill in everything that needs to go in our triangle. We know that this is our x value on a coordinate, and this is our y value, which means the x coordinate over here is -3, and our y value is 4. That's what we get there. Now, I want you guys to calculate quickly for me. You can use either cos, sine, cos, or tan. Find me the angle theta and tell me what your calculator says. Okay, pop your answer in the chat once you have that. Okay, tell me what it says, because I'm going to guarantee you now. Sorry, I'm just moving my camera. I need to get my calculator. There we go. Okay, I'm going to guarantee you now your calculator is going to give you something funky, but we need to talk about it. Okay, just pop your answer in the chat when you get there. Remember, when we're calculating for an angle, what do we need to click, guys? What do we need to click on our calculator?
What word that that word? Shift. Yeah.
What do we need to click? Did we forget?
The shift.
Yes, absolutely. We must shift angle. Yes, thank you. We must click shift. That's it. Absolutely. Hashtag shift angle. I'm going to make it trend, guys. Don't underestimate. Yes.
The answer I got
Hmm.
was 126,87.
Correct. Did your calculator give you that 126?
Yes.
Okay. Which one did you use? Let's see. Which one did you use?
I used cos.
Cos. All right. So we went theta is equal to arc cos of what?
-3/5.
Good. -3/5. All right. And if we do -3/5, it does indeed give us 126,87 degrees. Thank you. Did anybody else get a different answer? Somebody use, yes, Morangi. What answer did you get? Because I'm bringing it up for a particular reason. Morangi, you can unmute for me and let me know. What did you get?
Oh, ma'am, I don't know if it's like my calculator, but I did the same thing, but it's saying like 126.9 instead of 126.87.
Like, is it just 126.9?
Yes, ma'am.
Like no other decimals?
Yeah, it's just 0.9.
Okay, it might be a setting on your calculator, but we can talk about that in just a bit. It seems like
Yes,
your
ma'am.
answers are still going to be correct, but we do need to check why your calculator is rounding off for you. Okay, but we'll have a bit of a chat about that. All right, let me explain what I mean when I say we're all going to get somewhat conflicting answers. Now, Mandisa's answer is 100% correct. Yes, yeah.
Ma'am, I used sine, but y/r.
Yes.
So I got I shift sine and then 4/5, and
4/5.
I
What did
got
that give?
53.
53, comma?
I got 53,13. 53,13.
Correct, 53.13 degrees, correct. Okay, so definitely the answers that we're going to get here are going to differ. Okay, and I'm going to explain why. I need somebody to quickly figure out if you use tan. Somebody use arctan for me and pop your answer in the chat, or you can unmute and tell me. If we use tan, I know that this is my reference angle, this is the adjacent, this is the opposite, this is the hypotenuse. Or if you've learned the SYR, CXR, and TYX, you can also use that in this case. And I'll explain what all of that means in just a bit. Right, I know that tan is opposite over hypotenuse, so I should get 4 over -3. Can somebody tell me what answer does our calculator give us here?
-53,13.
-53,13. All right, so let's actually see what our calculator is doing here. Why do we have 3 different answers when in the other questions that we did, we all ended up with the same answer, right? When we did the first question, that one up here, everybody, it doesn't matter whether you used sine, cos, or tan, you were going to end up with the same answer over here. So what exactly is happening with this question that we're getting all these different answers? Now, let's think about this a little bit. Now, when we draw our triangle over here, when we draw our triangle, we actually know that the angle we're looking for is this one. This is theta, that angle. Now, this is not an acute angle. It's an obtuse angle, right? Which means it needs to be greater than 90 degrees, right? So what your calculator is actually doing when you punch in the values of sine, because sine is +4 over here and your r is positive over here, what your sine calculation has done is it's reflected this thing in that direction. That's what it's done. So it's used 4 over 5, and what it's given you actually is that tiny little angle over there, right? Now, lucky for us, we know that if this is a reflection, that means this part over here is also 53,13 degrees. And I know for a fact that if this x value over here is a straight line, how am I going to find theta if I know that part? This is a straight line. The x-axis is a straight line. How would I find theta from there? Who's got an idea for me? If I've got this 53,13 over here, I need this angle. And I'm giving you guys a hint. The x-axis is a straight line.
Ma'am, would you have
Ma'am,
Sure, I'm hearing quite a few voices. Let's see if we can.
ma'am, would you say 180 minus 53.13?
100% on point. That's it. Correct. Okay, so in order to find it, if we use sine, because it's the obtuse angle, well done, Oko, we're going to then go, therefore, the angle theta is going to equal to 180 degrees minus 53,13 degrees because of angles on a straight line. Because of angles on a straight line, we're going to get the same answer. So if I minus those two, then I'm going to get 126,87 degrees here. Now, let's think about what's happening with tan. Tan gives us a negative number, right? Tan gives us a negative number. And now, if I look at the way that my Cartesian plane has been set up, I go from 0 and I go clockwise to go to 90, which means my positive numbers are moving, sorry, not clockwise, anti-clockwise. So my positive numbers are moving in the anti-clockwise direction. Now, our calculator over here for tan gives us a negative angle. So in what direction do I need to move in order to accommodate for the negative angle? I'd have to move in the opposite direction, right? So I know that if I'm looking for negative 53,13, it'll be in this direction. It will move in that direction. So basically what's happening now is if this is 53,13 like that, what's going to happen is this is going to create a straight line. That 53,13 over here is going to create a straight line. Now, remember, guys, I want that part. I want that part over there. And now this angle over here is negative 53,13. How can I find the positive angle in the other direction? Are we going to do a 180 minus? Because here's what's going to happen if we do 180 minus. I'm going to get 180 degrees minus negative 53,13 degrees. That's not going to give me what I want, because a negative and a negative is going to give me a positive. So I'd end up with 180 degrees plus 53,13, which isn't really correct because this is going to give us 233,13. That's not the correct angle. Now, remember, guys, my calculator has given me the angle in this direction. I want my angle going in that direction. What would I have to do to figure out what theta is? Anybody got any ideas?
Ma'am, please repeat the question.
Okay, so the calculator for tan has given us a negative angle. Is that making sense? Yes?
Yes, ma'am.
When we calculate for tan, it gives us a negative angle. My negative angles move in this direction. I want theta, which is in that direction. Now, if my negative 53,13 makes a straight line over here, this now becomes a straight line. How am I going to find theta if I've got that angle? Instead of minusing, what would I have to do here?
You have to divide.
Oh, no, we can't divide it. It's angles on a straight line.
Ma'am,
These are
do you
still
add 180?
correct. We must add. Yes, absolutely. We must add 180 in that direction. Because this is a straight line, we're just going to add the whole of 180 in that direction. So we're going to end up with negative 53,13 plus 180 degrees, because we are moving. We want the angle that moves in the positive direction. So we will add. And if we add 180, we're going to find that our answer is also 126,87 degrees. Now, this is a very challenging idea. It's not going to be easy for us to get it on the first try, but we're going to keep going with it because our calculators are going to do funny things, but we need to think about where our angle is sitting. All right, let's look at another example of this. Okay, here we go. I want you guys, again, find me the radius r, and I also want you to find me theta. Now, again, watch how if you use sine, cos, or tan, it needs to give you an obtuse angle. So my angle must be greater than 90 degrees because there's my 90-degree angle, and my angle is greater than that. So if you don't get that for an answer, then we know that we need to shift things around a little bit. Right, I'm going to give you guys some time. I just want to double check. Give me a thumbs up, guys, if you understand what to do. Let's start there. Give me a thumbs down if you don't and you would like me to explain again. I'm more than happy to explain again. How are we feeling, guys? Oko says okay. Everyone else, are we good?
Oh, ma'am.
Okay, yes, I'm hearing. Ma'am, hi, Morangi. Yes, what's up?
Well, I just like a bit of a reminder of like the basics of like when we finding like the angle.
Mm-hmm.
Because like after we find r, like how we find that angle, man.
Mm-hmm. Okay,
Yeah.
so we know that r is actually the hypotenuse of this triangle that they've given us, right? Can we find r? Are we okay to find r?
Yeah.
Yes, right, because we know that if this is the x value, that means over here we've got the square root of negative 21. And if that's the y value, that means the distance from here to there, that is 2, right? So we can find that. So once we found r, remember, SOHCAHTOA, right? We'll start there. In order for us to find the angle, we first need to what? What is step number 1, Morangi? Always. Step number 1? Starts with an L.
Label.
Yes, absolutely. Label. We start by labeling. What is this negative 21? Remember, this angle that I'm looking for isn't part of my triangle. So I'm going to use the reference angle, which means it's the one on the inside. Is that one. So if we label in terms of this angle on the inside, what does this negative 21 become? Which side?
Ma'am, I think it's gonna be the adjacent side.
Yes, this is the adjacent side. Beautiful. What about the one over there? The 2.
It's gonna be the opposite.
Good. And the R side that we've just found will be our
Hypotenuse.
hypotenuse. Excellent. Now, Morangi, I'm looking for an angle. When I need to look for an angle, what do I need to do?
Yeah, ma'am, you do a SOHCAHTOA, man.
Good, we do SOHCAHTOA, but specifically when we're looking for an angle, what do we need to click on our calculator?
We click the shifts.
Good, right, shift. Now, let's think about this, Morangi. Let's quickly calculate R. Can I ask you to calculate R for me? Let's go ahead and calculate the radius. Okay, I know that I'm going to use Pythag, right? So I'm going to have the square root of negative square root 21 squared plus 2 all squared. Okay. This is going to give me, now inside here, the root and the 2 will cancel and the negative will become positive. So I'm going to get 21 plus 2 squared, which is 4. This 21 plus 4 is 25. And the square root of 25 is 5.
5.
Right. Good. So our radius is 5, which is great. Now, let's go back to our have versus our want. Now, look at my drawing, Morangi. What do I have?
Ma'am, you have 5, man.
5 is the what side? What side is that?
The hypotenuse.
Good. I have the hypotenuse. What else do I have?
You also have the adjacent and opposite side.
Correct. You have the adjacent and you have the opposite. Now, if I said to you, Namarangi, you have to use SOHCA or TOA. Which one are we going to use? Which one has these elements? Is it sine? Is it cos? Is it tan? Which one uses hypotenuse and adjacent and opposite? Let's not even say and, because really we only need 2 of them, yes? So we can pick which ones we want. Okay, let's say, for instance, correct, Desmarie, that's the point I'm trying to get at. If we decide to use the hypotenuse and the adjacent, Porangi, which one would we be using in SOHCAHTOA?
The hypotenuse and adjacent will be the CAH, ma'am. The
Yes,
cos.
what does the C stand for? Cos, good. So we could use cos, we want theta. So we know cos of theta is equal to adjacent over hypotenuse. But in this case, because we're looking for the angle, we're going to go theta is equal to shift cos. Remember when you click shift on your calculator, it goes cos to the minus 1, which is actually arc cos, right? And then we're going to open up our bracket. What is the adjacent side? How much is the adjacent side?
Negative square root of negative 21.
Good. Over what?
Over 5.
Good. So punch that into your calculator and tell me what your calculator says. Okay, Desmarie's got an answer for us. Sia, how are we doing? Now I'm saying Sia. Sorry, Morangi. Sorry, Morangi.
Oh,
Just to get
ish,
it.
ma'am, my tablet switched off, ma'am. So I'm only doing it now because it switched off when I was looking at the thing.
That's okay. All right. Let's go off everybody's answer in the chat because they're 100% correct. Okay.
Ma'am, I
We
see
get
156.
comma.
Ish, ma'am, you know my calculator is still having that problem, so I know the
Oh
decimal
yeah.
it isn't
Sure.
full.
Okay. So is it comma 4 at least?
Yes, ma'am, it says comma 4.
Okay. So it should be comma 4 2, but it's degrees, right? So we
Yes,
could
ma'am.
do that. Now, what I did, Morangi, instead of using H and A, I used H and O. Now, if I use H and O, which one am I using? Sine or cos or tan?
Ma'am, you're using sine.
Good. So now if I do this on my calculator, sine of theta is equal to opposite over hypotenuse. If I go theta is equal to arc sine, so sine to the -1 of, what is my opposite side? My opposite side is 2
Ma'am, it's 2
over.
over 5.
Good. Now, here's what happens when I put this into my calculator. When I put sine of 2, 5, what it gives me is it gives me 23,58 degrees. That's what my calculator gives me. Now, I know that my calculator didn't actually give me the correct angle because my angle is an obtuse angle. Do you see how it's a big angle? Yes?
Yes, ma'am.
So I know that this 23,58 is definitely that part over there. They've given me that part. What my calculator has done is it's taken this triangle and it's reflected it there. So it's given me that tiny angle there. But I want the big angle. I want the big angle. I also know that my x-axis is a straight line. So if I've got that angle, how am I going to find theta?
Ma'am,
If the x-axis is a straight line, we will
you plus by 180.
not plus in this case, because they're both sitting on the angle, we would have to, we're going in that direction. So instead of plussing, we would?
Minus.
Correct, we would minus. So we would go 180 minus 23,58 degrees. And that is also going to give me 156,42 degrees. Just like we did with the cos calculation, it just takes an extra step for us to get there. Okay.
Oh, yeah.
Is the math mathing now? Are we cool?
Yeah, ma'am, the math is mathing.
Good. Excellent. Good work. All right. Let's look at the next one. Here's the next example. Now, let's look at what's happening over here. I don't want you to give me R. I have R. You also have R. They've given you R. I want you guys to find me Y. Find me the answer for Y. And now I also want you to find me the angle theta. I want you to find me theta. Now, I want you guys to note that theta is not even an obtuse angle. This time, theta is a reflex angle. So watch the way our answers come out in our calculator, because now we're not going to be using a straight line. What are we going to be using to figure out the value of of that? Instead of the straight line, what would we use rather in this case? Because this is a reflex angle.
Opposite angles, ma'am.
Vertically opposite, or it's not going to, if we do vertically opposite, it's not going to give us what we want.
Okay.
Or we could use the revolution. Can we not? Angles around a point. Right. So we can either use 180 plus, we could do this, we could split it into 2. We could say that's already 180 degrees plus whatever that is, or we can use 360 minus whatever that is, and it's going to give us the answer we want. Okay. Or in this case, 270 minus what we want. But let's see what answers we get. Okay. Find Y for me, guys. And I'm going to just reiterate that this is actually a trick question, so we need to be very careful in how we answer it. Okay. Just plug my computer in quickly. There we go.
Ma'am,
Yes.
is the answer for y 12?
No, it's not.
Okay.
But you are almost there. It's okay.
Oh.
Rather than saying no, it's not 12, I'm going to say it's kind of sort of 12.
I forgot something.
I didn't quite catch that, Oko. Do you want to repeat that, my darling? I didn't quite catch it.
I forgot something. That's why it's 12.
You forgot. Oh, can I ask you to type in the chat for me? Because my, your speaker's breaking up a little bit, my darling, and I can't quite hear you.
Okay.
Ma'am,
Yes.
is the answer 12 cubed? I mean,
No, it
squared.
is not.
The
No,
square
it's
is it's not.
It's not. Right. I'm going to give it one more minute and then we'll chat. Because I'm going to guarantee everybody's forgotten the most important thing about Cartesian's planes. But we'll get there. We'll get there. Nope, it's not Oko, unfortunately. Okay, all right, let's quickly have a chat about this. Because for those of you telling me, excuse me, that my the value of R is 12, you're not completely wrong. Okay, so let's think about this. I know that if I wanted to calculate for the radius, right, the radius would equal the square root of x squared, or let's rather do this. Let's say the radius squared is equal to the x value squared plus the y value squared, right? That's how we would find this. Now, in this case, because y is the subject of the formula, if I move x over to the other side, I'm going to minus, right? So I'm going to end up with y squared is equal to r squared minus x squared. Are we all okay with how ma'am's done this? Cool, because I'm calculating for the y value. So I know y is going to equal to the square root of r squared minus x squared. Now, if we go for that, I know that my radius is 13, so I'm going to get 13 squared minus, then over here I've got -5 all squared. Now, if I put this into my calculator is going to give me the square root of 169 minus 25 is the square root of 144, which is equal to 12. I'm going to bet everybody got to at least 12, right? Most of us got to the idea that y must equal 12, but grade 10s, answer me this. What do we know about all the y values in this section over here? This is positive x, this is positive y, this is negative x, which is true because they've given us a negative x value. But what do we know about all the y values in here? Correct, they must all be negative. So even though my calculator gives me a positive answer, what my calculator has actually done is told me, all my calculator has done is tell me that the distance from here to there is 12 units. But I know that my answer in this quadrant for both x and y should be negative. So my final answer should be, therefore, y is equal to negative 12. So be very careful, guys. We're still working on a Cartesian plane. We need to adhere to the rules of a Cartesian plane. Okay, am I making sense, everyone? Because I feel like once I said no to 12, everybody was like, I didn't calculate right. No, guys, you did. You absolutely did calculate correctly. We just forgot that. Yes, yes. Okay, let's talk about it in a little bit more detail, Desmarie. Okay, these 4 spaces on a Cartesian plane are actually broken up into something called quadrants. Okay, they are called quadrants. Right, now, if I am in this first quadrant, this is called quadrant 1. We normally name it using Roman numerals. I'm not sure why. This is quadrant 1. This is quadrant 2. This over here is quadrant 3. And this over here is quadrant 4. Now, there are certain things we know about the values in here. I know that all my x values over here in quadrant 1, all my x values are positive. And all my y values are also positive. What do we know about the x values in here? What do we know about all the x values in quadrant 2? They're all what? Good. Yes, Palisa, 100%. All my x values are going to be negative, and my y values are going to be, because we're still in the positive y direction, they'll be positive. Correct, Wikanyo. I see you there, my darling. Good. Now, if we come down here, I know that my x values in this third quadrant, all my x values are going to be negative. What do I know about my y values over here? All my y values are also going to be negative. Correct. Now, on this side, what about my x values on this side? In the fourth quadrant, my x values, right, Michael, good. My x values are positive and my y values will then be negative. Okay, so we need to bear that in mind every time we are finding numbers, because your calculator is just going to give you the distance from one vector. Like how do we move from one inner vector, from one space to another? It's not going to take into account the fact that you are working on a Cartesian plane. So you need to know whether the x values are positive or negative in each of those quadrants. Am I making sense, Desmarie? Yes? Okay, let's just bear all of that in mind as we go into these examples. All right, let's talk about theta. Who's got an answer for theta for me? You're very welcome, my darling. Who's got an answer for theta? Okay, so remember, you can choose whichever value you want, right? You can either use sine, cos, or tan because you have them all now. This is negative 12. This is negative 5 according to our drawing, right? Let me just remove this stuff. So, okay, Michael says theta is equal to 75,52. I'm going to ask you, Michael, which one did you use? Did you use sine or cos or tan? You used cos. And how did cos give you 75? Okay, all right. Michael, remember, if I use cos, I'm going to use arc cos of, this is my reference angle over here, the one inside my triangle. So this becomes my adjacent side. That over there is my opposite. And this 13 over here is my hypotenuse or my R value, right? So if we look at how this is set up, Michael, if you want to find the arc cos is going to be minus 5 divided by 13. So we're going to take arc cos of negative 5 over 13. All right. And I'm going to assume Sia did you use tan for that? No, tan should give us a positive answer. Did you use sine? Oh, sine, yes. Theta is equal to arc sine of, if we use sine, we're going to get negative 12 over 13. And that's going to give us negative 67,38, right? Now, if you use cos like I did, you should get 112,62 like Mandisa did. And if we use tan, remember, you can choose any of those. All right. Thank you very much, Tseho. Tseho's got that answer for me. Tan or arctan is of negative 12 over negative 5 is going to equal to 67,38 degrees. Now, none of these answers are correct. Not a single one of them is correct. I'll explain. 112,62 degrees would be there. It would be less than 180. So it would have come all this way, but it wouldn't make it past the 180 degree point, right? Now, our negative 67 is sitting over here. That's where negative 67 is. So what my calculator has done is it's reflected the triangle, but it's reflected it down here in this case. And then for our positive 67, it's sitting over there. That is 67,38 degrees. And then over here, I've got negative 67,38 degrees. And the other angle on that other side, the one that goes all the way around like that, that's the 112,62 degrees. Now, we all know that we're all looking for that angle. We're looking for that whole angle. So let's work our way around the geometry to find the correct answer. Who's got an idea on which one of these we can use to get to the answer? Remember, my answer should be between 180 degrees and 270 degrees, because that is my full angle. What are we looking at? Okay. Tseho says 270 minus 67. Absolutely, that will do the trick. That will 100% do the trick. So we can take 270 degrees minus 67,38. What is that going to give us as an answer? Final answer there. 202,62 degrees. Good. Right. Now, okay, if I think about it, this angle over here has created a straight line, and that is also a straight line. Right. This is also a straight line in that direction. This tells me that this needs to be a 90-degree angle. Okay, so if I have 112, if I want to make it there, I need to add 90 degrees. Okay, which is going to take us to the exact same place as everyone else. So if we take 112 plus 90 degrees, it's also going to give us 202, oh, I keep writing 22, 202,62 degrees. Now, what about this negative 67,38 over here? How do we change that into the angle that we want? Okay, if my negative is sitting over there, I know that this over here is a 90-degree angle. I've got negative. How many degrees do I need to go in that direction to get it to be positive? Plus what? What am I plussing all that way? That's it, Palesa. Absolutely, yes. Plus 270 degrees. And that should give us the answer we're looking for. it should also give us 202.62 degrees. I just need to do a quick check-in. Thumbs up. Is everybody okay with how we're doing with these questions? Remember, we're looking for the kind of angle, and it does take a bit of geometry, but if we figure out where we're going, they all, yes, Desmarie, they're all the same answer. They're all 202.62. All three of them. It just depends on how we get there. Okay. Okay, let's look at some challenging questions. Okay, here's question number 1 over here, and then we'll talk about question number 2. All right. Now, I want you guys to note that in this question, they haven't given you a drawing. They haven't given you a drawing. They're saying here, point P, which is the point 3, 4, is a point on a Cartesian plane. You must go find your own Cartesian plane. We're not going to help you. You must find your own Cartesian plane. And then it says, XOP, which is our angle theta, is equal to theta, where x is a positive point on the x-axis. So x is a positive point, and we can tell that. And then it says, without using a calculator, determine the value of all of those, right? Which is going to be easy enough. First thing we're going to do is we're going to draw our own Cartesian plane. Okay, they haven't drawn it for us. Okay, I'm going to label the quadrants again. Remember, this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Where would the point 3, 4 lie? In which quadrant? 1, 2, 3, or 4?
1.
1, correct, in quadrant 1. So we know that both our x should be positive and our y should be positive. So we get 3 and 4 there. Right, and then we can do that. And okay, there we go. Now they're telling us that this is the x-axis, right? X, because x is the positive x-axis, and this is the point P, and our origin is always O. So XOP, the angle XOP, which is this one in between here, is theta. So now we're looking for the acute angle. It should be the smaller angle, right? Now I know that this is my x value, this is my y value. So that means I've traveled in that direction 3 units, and I've traveled up in that direction 4 units. Right, answer questions A, B, and C for me, guys, based off of what we know. And you can pop your favorite emoji in the chat when you're ready. Also, if you have any questions, please ask questions. Okay, if you're struggling and you're like, nah, man, please help me, I'm happy to help. Okay, but if we're being completely honest, we can't do anything until we find what? What do we need to find?
R.
R, absolutely, yes. Good stuff, my darling, well done. We must first find the hypotenuse, because your cos needs hypotenuse. Your sine needs the hypotenuse.
R is equals to 5.
R is equal to 5. Thank you very much. Okay, so this one was quite an easy one. We've done it before. R is equal to the square root of 3 squared plus 4 squared. That's 25. Therefore, R is equal to 5. So good. Now we can answer these 3 questions based off of this. Now, I want you guys to note, they're saying they want cos theta. Does that mean they want us to find the angle? Yes or no? Do they want the angle? Yes? No? No. Good, Michael. No, they don't. They don't want the angle. What they want is the ratio. They want the ratio of cos. So we know, according to SOHCAHTOA, cos of theta is equal to something. Okay, and that's what we're going off of here. All right. I'll give you guys 3 more minutes because we've run out of time. Okay, and it is quiz night, so we're going to have to hustle.
It's cos 3/5.
Yes, yes, sir. That is cos of theta, yes. Hmm. Two more minutes. There's Marie's done, which is excellent. Good stuff. Well done, Mandisa, with less than a minute to spare. Very nice emoji. Michael, I like it. All right, peeps, let's discuss answers. Okay, so Sia's already graciously given us the answer for the first one. Cos of theta, we know cos is adjacent over hypotenuse. I know that if I label, 3 is going to be my adjacent, 4 is going to be my opposite, and the r is going to be my hypotenuse, right? So cos of theta is going to equal to 3/5. That's nice and easy. Now, 3 tan of theta just means I need to take 3 and multiply it by whatever tan of theta is going to be. Now, I know tan is opposite over adjacent, so that is 4/3. And if I take 3 times 4/3, that's just going to give me 4. That's the answer I'm going to get. Now, this is half of cosec theta. Now, cosec is a cousin. Whose cousin is cosec, guys? Cosec is whose cousin?
Cos.
Of?
Cos.
Oh, it is not cos. It's
Is it sin?
sine. No,
Oh,
remember, cos and sec are cousins. So in this case, they want the reciprocal of sine. And where sine is opposite over hypotenuse, cosec is going to be hypotenuse over opposite, which means cosec theta is going to be a half times hypotenuse, which is 5, over adjacent opposite, sorry, which is 4. And then we're just going to multiply our fractions the way we see them. We multiply fractions, top, top, bottom, bottom. 1 times 5 will give me 5 over 2 times 4, which is equal to 8. All right. Okay, how did we feel about this question? Okay? No, and see Bukanya being like, ma'am, nah, ma'am, nah. It's okay. It does get a bit of getting used to. All right, here's another question. Here's another question that I would like you guys to quickly take a screenshot of. Sia, I'm glad you think so. Okay, take a screenshot of question 2. I want you guys to go try it.